another DraftScience video presentation. Probably mostly back on the subject of whatever, Vista Viva, whatever, living force, the kinetic energy equation that is just so bad. And so I did go looking for some better examples of people defending it anyway, and I found one by LaRouche, his organization. And it's it is funny that conventional physics agrees with LaRouche. I remember him from my childhood. He was a lunatic who ran for president every year. And got about 7 votes. But anyway, and the logic mistakes are just so egregious that you're just like, this is why physics has some problems. So anyway, I'm going to read some comments. This one sort of unrelated, but we'll deal with it anyway. What are your views on the ultimate fate of the universe? See, I just don't know why you care. I'm making all these videos about fundamental physics, and you want to know something stupid like, well, what's the fate of the universe? I don't think it has a fate, okay, any different than what it's doing now. It's probably just oscillating, frankly. The universe is what it is, and it's just vibrating. A little contracts a little, expands a little, contracts a little, expands a little, blah, 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 and it'll just keep doing that. And what do you think of dark matter? Well, obviously, I've said what I think of dark matter. I think it's obviously a God of the Gap, silly, extraordinarily silly solution to a problem. So they have 2 problems in physics. They have some motion in galaxies that doesn't make sense to them by their theory. They think galaxies are contracting, and they think the stuff is orbiting around a black hole in the middle, and so their math for that sort of arrangement doesn't work. The stuff on the outside is moving too fast. And then they have a bunch of gravitational lensing images that make no mathematical sense at all. They're completely breaking all the rules of the math. And so dark matter is just a convenient way of just saying, I'll put a little bit here and a little bit there and a little there, and I can fix all the mathematical problems. So it's just a God of the Gaps bullshit answer to a serious question of why their dynamics isn't working. All right. Sorry if I've already answered these questions. Well, even if I have already answered them, but the very fact that you're asking them is just really irritating. I mean, I've proved the double slits, the whole mystique around the double slit is absolute bullshit. I've demonstrated that this silly energy formula is nothing but claptrap, religious claptrap, living force theory. That it's just obviously religio-science, okay? It's not science. And I've given you a perfectly rational explanation for gravity. And yet, this is the crap you're going to ask me. What do you want me to say except, what the fuck? Alright, I read today that commonly held theories as to the existence of dark matter are now thought to be incorrect. By who? And, well, what's their counter theory then? Do they have some new replacement for the magical gremlins that fix things? Or, what, are they pixies now? Or some other kind of, they're just going to come up with some other bullshit then, right? They need some new bullshit to replace the old bullshit. So they're not going to let go of the old bullshit till they have some new bullshit to fix it with. So what's the new bullshit? Quantum magic glue? It'll be some kind of silly, stupid stuff. Anyway. Does this revelation appear to support your theories? I just don't know what you're even talking about. My theory never says anything about magical answers to questions. It doesn't believe in bent space. It doesn't believe in entanglements. It doesn't believe in any of the wooey bullshit, the superpositions. All of this crap is that. It's crap. Dark matter, dark energy, just bullshit. There's no such things. There's gravity. And there's charge in the universe, and that's it. Theoretically, that's all there is. Charge is just magnetism is just a manifestation of the existence of charge. And gravity is just a manifestation of gravity. The fact that there's energy in the universe. Alright, anyway. I'm going to delete it. No offense, I'm just saying these are not... It's just not rational. I mean, I'm talking about pi equaling 4. People arguing that pi equals 4 and doing crappy experiments and sort of demonstrating that you can do crappy experiments and prove something with a crappy experiment. And that's a real problem, and we all should have our eyes open, okay? And the whole point about arguing the two-slit thing is that 200 years ago somebody did a crappy version of the experiment, and you're sticking with what he said, and it was a crappy experiment. I mean, it's just amazing that, you know, people can't get over this, and they're just keep trying to dig up an artifact to prove that, you know, life is something different than this determinism thing they can't deal with. But anyway, it's just not relevant, for fuck's sake. All right, in the whole video, you say if charge. No, what I said in the whole video twice was let's do the experiment. I said that overtly, and let's do it for money, okay? Because your people are being really obnoxious. You think your physics is correct, okay? So there's millions of you who are saying it's correct, and you have all the talking heads, and you have tons of money. You make colliders, you do all this crap, you spend money on LIGO crapola, billions and billions of dollars. I'm just asking you to put up a little bit for the trouble. And yes, then I'll commission the experiment to be done, okay, by somebody competent to do it, okay? Nice machined things, nicely done. It's going to be really kind of simple, okay? It's just going to be things rolling, and then they're going to hit a spring, or they're going to hit a lever, and they're going to exchange their energy. And we're going to see what they exchange. And there won't be any noise, and there won't be any sounds, and there won't be any of this bullshit for you to say half the energy disappeared in some bizarre way. All right, and we'll agree on the experiment, and you'll tell me you're predicting a certain result. You say something has twice as much energy as this thing. We're going to drop the two things, so to speak, on a real spring, and we're going to see if they have twice as much energy, okay? So fuck you in this bullshit. I'm asking you, let's do the experiment. Unless you have the experiment already done somewhere. So if you just link me to the experiment already done where you prove that you got these 400 or 500 joules of energy out, if you can show me you doing that, then the whole thing is moot, okay, and you win. But you can't provide any evidence, you bastard. You piece of shit. Anyway. If I change this or that, it'll end up the same. Why don't you do it? So now he wants me to do the math thing. Look, I already pointed out that all the guy's doing in the mathematical equation is showing you how the energy is converted into gravitationally potential energy, and then it swings back down by the laws of gravity, and then it does the same thing on the other side. And I'm just pointing out to you that if I use the number 5 over here to say it's 5 energies, it's obviously going to be 5 energies on the other side. Okay, so it's a closed experiment. Whether I said it was 3 or whether I said it was 400, it doesn't matter if I got a wrong answer for how many joules of energy it has, because I'm using the same number in the other direction. So if I use the same error in both places, the error doesn't mean anything. So he wasn't using 2 different sized weights. He wasn't doing anything that would be illustrative on this subject. So do you really want to waste it? Do you really want me to waste my time and the audience's time doing something that's obviously can be done? All I can do is just erase half of what he put on the board and just replace it with the number 5 and just say, well, let's just put 5 in the equation and see what happens. And the same thing will happen. It'll all end up being 0. Because all he's really measuring is this is equal to this. Duh. God, people are such dumb fucking pieces of crap. For example, for the pendulum example, you said if you change the formula for kinetic energy with mv, you would end up with the same equation. You'll end up with the same result. This will equal this. Duh. That's what gravity does. You throw something into gravity, it gives you exactly what you throw into gravity, it gives you exactly the same back. Right? Doesn't matter how much velocity I throw it up with, doesn't matter what I do, I'm going to get the same fucking thing back. God, you people are so obnoxiously stupid. Anyway, so end up with the same equation. There's no equation, okay? There's just a comparison of this to this, okay? And it comes out 0. Of course you will not, but why don't you do it? Because I watch the video, and all the time you say if I'll try to find excuses for not doing something. There's no excuses here. Again, I'm saying you put up. So if you know, just say in the comments if you're willing to put up $500 or $200 to defend your physics, I'll match it. All right, and we'll have a real contest. I mean, you know, obviously before the actual experiment, you're going to have to put up some sort of credentials to make sure you got the money. But anyway, you know. It's a real challenge to you assholes. Put your money where your big, fat, ugly, smelly butthole mouths are. Okay, why don't you just do it? Take the kinetic energy MV and see what happens. See what will happen. Again, he didn't do an experiment, you insane lunatic. A mathematical formula does not prove that a train going 10 miles an hour that weighs a ton somehow has less energy than a half-ton train going 20 miles an hour. How's the formula resolve that issue? How's the formula tell us how many joules are in those two trains? God, you're such a putz. Anyway, you can also do the experiment, take two masses, measure the velocity so they have the same momentum. Yeah, exactly what I'm offering. Exactly what I'm saying. Right, if we can't find the experiment already done, then let's fucking goddamn do it. And let's do it for real money. I mean, I'm calling you an asshole. You're calling me an asshole. Let's do this for money. Let's do this for something real. Then, I'm going to have the satisfaction of going, nah, you people are dumb fuckers. No, I want more than that out of this. I want more satisfaction, fuckface. You're being a obnoxious pile of shit, all right? And all I get is, I get to say he was an obnoxious pile of shit. No, I want more. Okay. And see if they will compress the spring different. Well, again, if you don't know what the answer is already going to be, you're really fucking stupid. So that's why nobody's saying anything. No one's pointing me to any videos proving it. Because the fact is that every rational person knows that if I put a spring there, two springs, the same exact spring, and I put the 20 mile an hour 5-ton train, and I put the 10 mile an hour 10-ton train, and I crash them into that spring, they're going to compress it exactly the same amount. Because that's what springs do. Springs are even compressors. Okay, the force goes through the spring very evenly. It doesn't have a bias for fast things or slow things. Like I can jump on a scale and it will measure my extra velocity. It won't be fooled by it. It won't measure too much or too little. It'll measure the actual momentum. Springs can measure momentum. Gravity really sucks at it, because gravity, to get twice the velocity, you have to go 4 times as high. Because gravity, as I will explain eventually, you're collecting it, okay? So the more mass you have, the more of a collector you have. It's like having a sail collecting wind. If you put a little sail on your boat, it can only collect a little bit of wind. If you have a big sail, it can collect a lot of wind quickly. That's why if I take those two trains and I put them on a pendulum, well, yeah, the faster train will go higher, because it's lighter and it's collecting less wind. The heavy train will go slower, because it'll go less high into the gravity, because it collects all the energy much quicker. It collects the 18 joules of energy here, where the smaller object, the less dense object, the less material object, the less massive object goes much higher, because it takes longer to collect 18 joules of energy. Dumbass. I mean, this is so stupid. I mean, again, I can't even imagine. I mean, in grammar school, I understood that, the mass and you could just invert the mass and the velocity any way you wanted to, and it's always going to be the same momentum, and it's always going to compress the spring the same amount. I mean, this is stuff you learn in grammar school, for fuck's sake. I guess they don't teach it anymore, but, I mean, I learned it. 2 plus 2. This is like 2 plus 2 kind of math. That a lever isn't magic. A lever isn't doing a magical thing. Levers are allowing you to take more time to lift something. That's what it's really doing. It's allowing you to take the weight and make it lighter by giving you more time to lift it. But it's not doing anything magical. It's not allowing you to find the living force and take advantage of it. A lever is another good way to test this. We could have one train going one way on the lever and the other train going the other way on the lever, okay, and just let the two opposing forces, so to speak, interact with each other. Okay. So I just can't believe he said this. You can also do the experiment. Take two masses, measure the velocity so they have the same momentum. Yes, so exactly. Just invert the velocity and the masses. One of them has half the velocity, one of them has half the mass. Right, exactly. Do that. So they have exactly the same momentum. and see if they will compress the spring different. So again, these people actually believe this crap, this experiment, if we actually did it, they actually think the spring's going to be twice as compressed by the fast light thing. That I could throw Tweety birds really, really fast, and somehow I can, knock, redwood trees over because I have so much extra energy. God, you people are just so stupid. Even the bullet analogy, you think they could get that? Like if we had two masses and we stopped them with guns, that would be kind of a fun way to stop something from moving, right? Just fire a gun into it, and you just take two big hunks of plastic and put them on, sleds, and you just say, how many bullets does it take to stop the thing? You got to know it takes the same number of bullets. Shit. I just can't believe I have to have this argument. It's incredible. I mean, you're incredibly stupid people. Also, I have a question for you. If I have a body with mass m and I impose on it a constant force, so see, this is where you get into trouble because you don't understand what these constant force. Gravity is a constant force, right? But in the first second of motion, it doesn't move you 10 meters. It only moves you 4.8, half the distance, 5. So even though it's a constant force, it takes time to accelerate. Okay, so acceleration isn't instantaneous. You don't just hit the wind and the wind instantaneously pushes the boat. It takes time for the force to be converted into motion. And that's the truth with gravity. Now, if I take a steel ball and I bang it into a steel ball, well, then I'm going to have a pretty instantaneous transfer of the energy. The ball's going to have to leave fast. Okay, it can't wait to gain its velocity. It can't gain it over time. But that's the trick of gravity, right? So even though it's moving you at 22 miles an hour, right, after 1 second. After 1 second, you're moving 10 meters per second, but you haven't traveled 10 meters of distance. And that's why you're getting fooled, because you think distance is velocity, and it's really not. You could argue that the thing is going much faster because it only went 5 meters, and you put 5 meters of distance into the 22 miles an hour that you gained in velocity, and you'd end up saying the gravitational force should be a higher number. But we understand that the force doesn't instantaneously cause velocity. It works on your little bits and it gives you velocity, and after 1 second of working on you, you'll have that velocity. But in the first second, you won't. I mean, the first millisecond, you won't. Alright, impose on it a constant force F. What it will be, the velocity, I guess he meant just what will be the velocity of the body at time t2. So again, you're playing games with applying a force, and as I just pointed out, I can apply the force in all kinds of different ways. If I hit a steel ball against a steel ball, I'm going to be applying the force in a millisecond. It's going to take literally just a millisecond for all of the momentum to be transferred from one thing to the next thing. Now if I'm applying gravity, that's like a wind going through a sail that has holes in it. Not all of the wind hits the sail, and it takes a little time for it to impose its velocity. So time is irrelevant. We're talking about something that either has the quantity or it doesn't. The quantity is joules of energy. The train moving, theoretically, we're talking about perfect tracks, no losses. The trains would go forever. All right, so we're talking about what's its momentum now and what's its momentum 6 hours from now. It's the same momentum. It's moving at a certain velocity and it has a certain mass. Its mass obviously isn't changing, and the argument is its velocity isn't changing. This isn't about some t1 time thing and t2 time thing. This is about the transfer of the energy. And we're arguing if we transfer it rather efficiently, like a spring is pretty efficient. There's not too much losses to heat. There's not too much losses to too many things. All right, so it's just going to be, we're just going to convert it into compression of a spring and let the spring push it back again. That's it. So where we have to worry about T2s and T1s and any of that crap? Really don't. Okay, let's take the initial velocity 0. Can you find the answer? Why would I bother? How does that get to the core of this question? You're saying that two things with the same momentum, right? A train going 10 miles an hour, that weighs 2 tons, and a train going 5 miles an hour, 20 miles an hour that weighs a half ton or 1 ton. You're saying that those two trains don't have the same energy. You're saying the fast one has twice as much energy. All right, and all I'm asking you to do is show me you extracting that. Okay, momentum says they're the same. The two things aren't compatible. Okay, you either believe in momentum or you believe in living force. So you're going to have to pick a side because the two are intrinsically out of sync. The two of them are getting a different answer without even touching anything, without anything banging into anything. You already have something that doesn't make any sense. They can't have the same momentum, and then you're going to argue, but one of them has 500 more joules of energy. You can't do that. It's completely irrational. All right, if you can't take, you move, then 10 minutes. If it can't take you more than 10 minutes. Okay, so he wants me to do the integral of figuring out the transfer of energy or something. Why would I do any of that? This is again, it's a simple proposition. You just already said it, okay? You said if you were going to put money on it, you'd say that the spring will be twice as compressed by the lighter train going fast than the heavy train going slow. You're saying the spring will actually be twice as compressed. That's your assertion, right? You're saying kinetic energy is real energy. Okay. Is there any other debate here? No. Okay. But I don't want drawings. Just write the answer. V equals. No, frankly, I don't even see a number in here. I don't see any numbers. V equals, you didn't give me anything. Initial is 0, and the force is what? There's no force here. You didn't give me what force you're hitting it with. Oh, you're just irrational. All right, and how you come up with the answer. So I don't know. Have a body of mass m and impose it on a constant force. Are there any numbers here? No. What will be the velocity of the body at time t2? I mean, this is incredible. So there's no times, there's no mass, and there's no force. And he wants me to say what V equals. Huh? Yeah, sorry, that would be just stupid. Okay, the velocity, it's obviously going to be, depends on how you apply the force. So again, you don't really realize that forces are all different. You think every force is the same. So every force is like gravity. Where you have to go 4 times, you have to move the spring 4 times, you have to compress it 4 times back to get twice the velocity. You think a spring works that way. So springs and gravity, exactly the same. No, they're not the same. Gravity is sort of a unique case, okay? Gravity is a unique case. Gravity takes the same amount of energy, right? I shoot 2 things of different masses, all right, at the same velocity, and the lighter one goes much higher, 4 times. You get it? I mean, gravity doesn't give you the right answer. If I want twice the velocity, I have to go 4 times the distance. Likewise, if I do the same thing where I'm getting twice the velocity, okay, out of a body, two things weigh the same, and I shoot them up. The one that's lighter is going to go 4 times higher. To get to the same velocity, it's going to go twice as high. So to get to the same velocity, it's going to go twice as high. That's not like the regular spring. So you're just a dumbass. You think all forces are the same. So 2 steel balls hitting each other is the same as gravity. It's instantaneous. You achieve gravity gives you the velocity instantaneously, and yet somehow you only travel half the distance. So even though gravity instantaneously made you go 10 meters per second, somehow you only went 5 meters in a second. So why don't you explain that? Why don't you explain that, how that's the same as all the other forces? Fuckhead. Yeah. Alright, so I'm deleting it. Fuck you. Put your money where your fat mouth is. Come on, put up 1,000. I mean, you should be really comfortable, voting with, all the talking heads of physics, right? All the talking heads of physics will agree with you. So you should be able to put up some pretty good money, but you should be pretty certain they can't possibly be full of shit. I mean, Physics Girl couldn't possibly be a silly dupe, could she? Yeah, maybe she could. I mean, her video was so goddamn stupid. I played the video, for fuck's sake, twice. You really think you can completely transfer the momentum? Completely. No heat losses. No nothing. Completely transfer it, okay? You were going 10 miles an hour, now you're going 5 miles an hour, and you have twice as much mass, right? I mean, it's that clear. All the momentum was transferred. No losses. And then claim, but we lost half the kinetic energy. And that makes sense to you. Fuck. Alright, Bob Ribble. Ignoring other forces, friction, gravity, etc. Well, all the forces matter and they all apply their force differently, with greater and lesser efficiency. If I roll a marble towards another marble with the aim of causing a domino effect, kinetic energy predicts different speeds. Exactly, which doesn't make any sense for each marble than what momentum predicts. Yes, it is clear to me that these systems do not gel. Yeah, exactly. There is no, what was the word in the Wikipedia page? They're complementary or something. That's the bullshit language they used. Yeah. Okay, the two theories are now understood to be complementary. How can they be complementary? They're getting completely different answers. And they say, it's complementary. You can keep momentum. It's just completely wrong. But yeah, why not keep it? For fun. I mean, how is it complementary? They're two entirely different descriptions of the truth. The answers are different. 5 and 10 are different answers. How the fuck is that complementary? What am I doing here? Anyway, well, at least that guy got it right. Okay, so, and independent. Yeah, sure you are. What about, it's AN maybe. What about dropping the two different objects from different heights? So again, the height thing fools you, right? Because you go, I want twice the velocity. And you think, I just go twice as high. No, you have to go 4 times as high because of this whole thing where you're only accelerating half the distance, right? Even though you have the velocity, by the time you wait 1 second, you're now going the right speed, but you didn't travel the right distance to do it. So that's the problem with using gravity. Gravity's excellent at being conservational. That is, it's really great at giving you exactly what you give it, right? I throw the thing up, it gives me exactly the same amount of energy, bringing it back down again. It throws it back at me at the same exact speed. So it's really good at doing that. But it really sucks at doing the, comparing two objects. Because again, it's the size of the sail. The number of pieces of matter you have, each piece of matter is really doing the collecting. You always have to recognize that it's a nuclear force. It's affecting atoms. It's not affecting objects. It doesn't care that I am this size. It only cares that I contain this number of atoms. All right. Let's see. What about dropping two different objects from different heights, such that the time the objects make contact with the spring, they'll reach the desired speed? Yeah, well, again, we just have to do the spring thing. The spring is probably the way to do it. This might be a better way to measure. Like I said, if I take a lever and you force the two things to push into each other, right? well, if it's going, well, anyway, that would be a good, it's going to basically tell you that if they hit at the same time and one of them has a different amount of momentum, well, it's going to go wherever way the thing with the more momentum is. And what I would argue is when the two things hit the lever, right, the lever's not going to, it's not going to say, oh, the fast thing has more energy. All right. They've reached the desired speed. Then measure how much the spring deforms when impacted by ideal high-speed video. Yeah, well, it's much easier just to put this on a track, right? Just have two ball bearings of different masses, and then you push them at, you drop them from different heights on the thing to ensure that they have the correct velocities. So one's going to be moving faster, one's going to be moving slower, and just let them roll down the track into a spring. Yeah, and see how far the spring's compressed. The end. But see now, just to make sure that they're not going to lie, you know what I'm saying? I mean, like I said, the physics girl, this video is such a great example just because they're going to say something like, well, there's magical hidden kinetic losses, So you have to make sure it gets to the point where, there's no excuses. So I'd almost like to do the reverse conversion, because see, their theory basically says that if I keep hitting big things into little things, if I keep converting something with more mass into things with less mass, that I'll be making energy. It'll be free energy because I only put 16 joules into the heavy thing, and I'm going to get 32 joules out of the light things. See, that's the magic of their theory. Okay, is that I'm actually going to get more energy out when I make them go faster. So the faster I can make something go and the lighter I can make it, the more energy I can actually pull out of it. So I'll go from having 16 joules to having 32 joules by having an impact. So that's the experiment I really want to do, because that's the one to really show how ludicrous what they believe is. All right. So Rob Ribble. It is Ribble. Does the friction experiment bias towards velocity because faster objects are less exposed to opposing forces? Well, you could sort of say that, but it's obviously less sticky, right? So it's almost like running through fire with bare feet. Sort of. I mean, not only do you have to not stand in the fire very long, right? I mean, obviously it's a different principle, okay? The heat is actually creating a little cushion of steam between your feet and the actual fire. But the point is you do still have to move fast. And the faster you move, the less the heat's going to have time to make contact with you. So certainly that's part of the advantage. But the other part to recognize is that most of these friction experiments, you're talking about gravity is also pushing objects down. So the ones that have more mass are collecting more energy from gravity, clearly, right? It's the same argument as the gravitational. They collect it much more efficiently. More matter, more mass, more energy collected per unit of time. So in a unit of time, the heavier thing is collecting more pressure, pushing it into the surface. And obviously the more I dent the surface, it's like being in a pothole. And your wheel's spinning in the pothole. I mean, obviously I can make the friction worse by deforming the surface. And if I deform the surface, I'm making the friction even more capable of preventing me from getting out. So you make the friction more, you make it more possible for the surface to have interaction because you're pushing one piece of matter into the other piece of matter. And you're more likely to create vacuums, where you've displaced all the air, and so now you have a vacuum holding the surfaces together. That makes it even stickier and harder to push through. So you're more likely to have all those kinds of effects the more pressure you're putting down on the surface. All right, but like I say, you can fix that, as I pointed out, right? If we put things on carts, right, we just put 10 pounds on one cart and 5 pounds on the other cart. We just have to know, okay, to be fair, the cart that has 4 wheels, we have to put 8 wheels on the other car, that kind of thing. So if you're going to do some braking experiment with a car, you have to know, well, if I want to increase the velocity and for one car, and I want to increase the mass for the other car, that obviously I have to give the one that has more mass, I have to counter for that fact, I have to give it bigger wheels. right? I have to make it possible for it to create more friction, the same amount of friction per mass. So you have to have the same surface areas on your brake pads, and you have to have the same surface area on the road rubber, and you have to have the same compression of the rubber to the road. So as long as you do all that stuff evenly, then the two cars will stop at exactly the same place in the same time. You know, you're only breaking the experiment by giving the one that has more energy the advantage by saying we're going to use the same braking mechanism. Well, you can't use the same braking mechanism, say it's a fair contest, because you know if you made one heavier than the other, you would obviously be cheating. All right. Probably can leave that. All right, so that's enough of that. So I'll come back in the future. I'll finish this video by just explaining again what gravity is, and I'll play the LaRouche video thingy that's just so bizarre and funny and weird. It's just a bizarre video, you know, defending this crap. You know, it's just that crap. What, is this the right video? This one has this stupid balls in it. Yeah, no, I don't think that's the same one. Yeah, this is when that one was even worse. Let's see. I think it was this one. Yeah, this one I think's the. Yeah, this is the LaRouche one. It says right there. So somewhere around here they do an experiment. This gives it all away. So they're doing the pendulum experiment. So they roll two balls and pretend to capture them and then allow them to be moved up by gravity. Obviously, the heavier ball, the big one happens to be the heavier one, so they're making weight proportional to size. The heavier one, as I just said, as soon as it moves into gravity, it's going to collect more joules of energy because it has more atoms to collect it with. So it's going to collect the opposing force much quicker than the other one that has a less mass. It has less mass, so it can't collect it as quickly. And it's just that simple. Obviously, the heavier object is going to slow down quicker because the heavier object is collecting more opposing force. Much quicker. All right, anyway. I mean, so this is so bad. So conventional physics actually agrees with these lunatics. You know, which is just really funny. Who would have thought? You know. So. All right, well, till then and such. So I shall pause. What will likely be quite a bit of time for me will be quite brief for you. All right, I should be back. Yes, a few hours later. So anyway, I guess I'll just clean up yesterday. Somebody, the guy who made the comments, whatever his name was, the 3-letter name guy, left some snarky comment about how I deleted his comment and blah blah blah, and so I just blocked him. Because what's the point of the argument? It's just this snarky crap back and forth, and there's absolutely no substance to their counter arguments in terms of actually producing any information, any links, any data, any experiments that demonstrate what they argue. Now, I did find this LaRouche pack, whatever. I guess it's something I think he's dead. He's left behind some political thing, and it's just now some sort of LaRouchian religion, and presenting the argument between Descartes and Leibniz, in a sense, on this subject of energy and its nature. And so they quote mine, Descartes' arguments. But both of them, if you look at both of their structure of theory, what they're basically saying about conservation and the transfer of energy, they're both the same. It's basically the same argument, and it's kind of funny how it goes. It gets crooked based on this idea of these bad names for things. So Leibniz was basically calling things living and dead force, and essentially you could call that potential versus, the dead was called potential energy, and the active would be the living. It's clearly still wrong to put the square on it because it's only based on certain experiments, and so this illustrates the idea that depending on how you do the experiment, you'll get a different result. So I could provide an example, I suppose. For example, if I wanted to measure acceleration in a circumstance, you could understand that I could just shape something. So say I have a wind, that blows in a certain direction, and I say I want to measure the force, and I want to come up with an equation, and blah, 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 to define how energy is transferred from one object to another object. I mean, you could understand that all I have to do is change the shape of my sail, so to speak. So if I put a sail pointing, I put a point on it, obviously I'm not going to collect much of this energy. It's all going to get moved this way, and I'm going to say, oh, the force equals lame. It doesn't have any, it doesn't, it's not very effective. It's a 0.02 force. And all I do is change that shape of the sail, and make it something that catches the force. Force can't get out, and now all of a sudden I have, a force and acceleration, all these things, shoot way up, and it's mega acceleration and mega force and all of that. So just depending on how I do the experiment, I can change the outcome, and that's all this is about. So, a couple of 100 years ago, 300 even, they hadn't really chronicled all the experiments. They really didn't have enough data to draw conclusions. It's almost like the evolution argument. Some animals made it some kind of obvious, other animals make it kind of difficult to explain. The flounder with its eyes on the same side of its head and different things, they can fool you. And so, you can misunderstand how the thing actually works. And so the interesting thing is Descartes used things like the quality of motion to describe it. But none of them really thought motion was something inside the object, that it was like a quantity, that you had 18 of something or 29 of something. And that's where the physics failed, is not getting this simple principle, I would argue, that you acquire motion and that it does cycle through the universe. Now, see, even Leibniz understood that, well, his explanation for why his theory didn't fit in the circumstance where two pieces of clay hit each other or something, is because he said, oh, there's all this internal motion, all the little bits inside are going in all kinds of different directions, and that's why things don't go anywhere. And so that theory is sort of correct in understanding that the motion is something it has, okay, and you have to follow where it goes. So it's all conservational because every unit of motion, it goes somewhere, any bias. And that's, I guess, the key thing too, is they really couldn't understand, is that everything already has a whole bunch of motion in it, and it's just that it's equalized. We're all in the same condition. Everything here is actually moving through space in a direction, but we can't see it because we're all doing exactly the same thing. So we all have a bias of 5 in this direction, because of the way the fields are all interacting with us. And 10 minutes from now, it might be a bias of 10 in this direction, depending on how all the forces are interacting with us, how the universe is exposing us to force. And in every moment, these things change, and that the change is something that the matter is fundamentally able to do. Now the trick is, it depends on how far down you go to the matter bits, and the key, I would argue, is understanding that the nucleus of the atom has a feature. That's the place where the energy is actually stored. That's the place that creates an engine that can maintain velocity. So I would argue that's an arrangement of protons and electrons where the energy is trapped, and where if you compress it, it fights back, and all of that kind of thing. So that the engine is the helium nucleus. And so what you're really doing is just pointing all of your helium nucleuses, in a sense. So when you're exposed to a force like gravity, what the force is doing is it's turning all of these little nucleuses. It's turning them, it's turning them and turning them. So the longer you're exposed to the force, the more nucleuses it can turn, and therefore provide more units of velocity. And a unit of velocity is just having how many you have going this way, versus how many you have going that way. And if you have 3 going this way and 2 going that way, well, then you have a bias in that direction, and you just add up all these little nuclei vectors, and it tells you what your velocity is going to be. What percentage of your nucleuses have been biased in one direction, and that'll be your velocity. So the longer you're exposed to the energy, and the more mass you have, the more places you have to collect it in terms of a bias, the faster you're going to end up going. And so that's why it's just mass and velocity. Mass is the collector. Mass is the sail. The sail is going to tell you how much wind you catch, and it's always going to be that relationship. There's no trick to it beyond that's the only mechanism there is. There's no other way to acquire it. And so the only other question is obviously with the forces affecting these bits by collecting energy that keeps raining. In other circumstances, you're not hitting something with rain, you're hitting it with a giant avalanche of energy in the purely elastic collision, and you transfer the total amount of energy very quickly. You don't do this blowing on the sail thing. You hit the boat. Okay? So it's a different way of interacting, and so they try to come up with a force law that's saying the same thing, that's saying somehow this force is the same as this force, when they really can't be the same. The forces have to be conveyed in a completely different way, and one of them is completely time dependent and the other one is completely time independent. So there's no point in trying to force them to fit into one equation, just as there's no point in saying driving a car that has an aerodynamic shape, and that it's the same difference driving it backwards as it is driving it forwards. Obviously, it's not the same. Alright, so that's probably enough of that. We'll go back to the video, and then we'll do some more on gravity and try to explain why most of this problem is that 300 years ago they really didn't understand the concept of what things would do in empty space, so to speak, in some kind of clean environment. So everything was measured based on Earth, and they didn't even really understand what gravity was, or they understood enough to know. Galileo had already explained different things. They really didn't understand the difference between the fact that the quantity of energy, the amount of bias, prejudice something has, its velocity in a direction, can be peeled off. It can be collected as just real energy. It's a real bias, and it's really dependent on the mass, and you collect it off of the masses that are moving. Each atom is a little piece of energy moving through space, and you collect its energy. And so it's a quantity. Velocity is a real quantity, and you can just add it up. How many mass bits are moving how fast, and that's your absolute energy. All right.
Inverting the statement, the height to which a body can ascend is measured as the square of its speed.
So this is to understand that the gravity affects things. I probably should have just drawn that drawing earlier. And I also should have made an eraser, which I didn't do. So, where's my eraser? Eraser. Not even findable at the moment. Ah, there it is. Alright. Quick, well, it won't be that quick. But regardless, you'll have to do, as I often say. Because life is difficult, so you can't do it perfectly. All right, so gravity has this circumstance. If I, the velocity, if I drop something from this height with a velocity that's, v1 or whatever, 1 unit of velocity, and I want to double the velocity, I have to go 4 units of distance. Okay, so it's like an inverse square law, but it's really not based on the same thing as an inverse square law. It just has to do with the fact that gravity imposes the acceleration at half the rate. So you have to just understand that it's only half what would be if it was instantaneous. So if gravity was like a steel ball hitting you, okay, then you would get 100% of the energy instantaneously, and you'd instantly move 16 miles an hour, or whatever the amount would be, and that would be it. 10 miles an hour, 22 miles an hour, or 10 meters per second. You'd move it, all instantly, from the first moment you encounter it almost, and you would go the full 10 meters in 1 second. But gravity doesn't work that way. You have to collect it. And so the collection process means that yes, you will be going 10 meters a second. You will be going 22 miles an hour by the time you get to 1 second, okay, of distance. But the distance will only be 5 meters instead of the 10 meters. So the acceleration is half the rate of your velocity. And so that's why you have to add up. Well, now it's going 10 meters a second, plus it's going to go another 5 meters because of gravity, but it's going to go a full 10 meters because of the fact that you've already given it velocity. So it goes to 10 meters from velocity. It goes a new 5 meters plus the old 5 meters, so it goes 30 meters, in the second. And then, you go down and down. It does the same thing. So it just keeps, your velocity is increasing, but it's only adding 5 meters per second of actual new distance. It's only adding 5 new meters, and it's your velocity that it has given you that is making you go much further. So your velocity starts taking over from your acceleration. It becomes a much bigger portion is your net the velocity you have acquired becomes substantially more important than the small units of acceleration. And the other way to look at it is that so that's what's going to happen to something. And the same, you can see that a similar effect with as you change the masses, because a small mass, okay, versus a big mass. So if this mass is twice as big as this mass, that means it collects force twice as fast. So while this one in 1 second only collects 1 unit of energy, this one in 1 second collects 2 because it has 2 masses. And you go up here to 2, and then this becomes, well, it has 2 masses plus 2 is 4. And so you can see the relationship is not equal. You'll be affected by, the force has to push harder on the heavy thing. The fact is, the heavy thing collects more energy, is what to understand. That's why the heavy thing hits. Even though they're going exactly the same speed, the heavy thing hits with a much bigger amount of energy because it collected more energy. It has a bigger sail on the boat. The boat's the same, you could argue, and all that matters is the size of the sail. And the size of the sail is your mass. That's your collector. And so the same thing happens when you're going down in gravity. It's when you go up against it. So if you go up against it, a heavy thing is going to collect energy much faster. So if this thing is 4 times the size of this thing, you can understand that it's going to take a very short period of time. This one will collect 10 units of energy, let's say. And so if it has 10 units of energy going in, it's going to be very fast. In a little over 2 seconds, it's already going to collect the 10 units. Where the thing with the 1 mass going the same exact speed is going to take 10 units of time, okay, before it has collected 10 units of energy to counter the 10 units it came in with. So the velocity is a unit of energy, and it's basically, you're just saying how much mass. The mass is just saying here's how big your collector is, how fast you can collect energy. And that's what you're doing in gravity. You're collecting energy. And the more mass you have means you have a bigger sail, so to speak, to give a simple metaphor. And it works. I mean, it's perfectly consistent with what happens. It's just to think of mass as the sail for collecting energy.
So now return to Descartes. He says that an object of mass 2 and speed 1 has the same quantity of motion as an object of mass 1 and speed 2.
Right, and that is what Newton would say also. So it's just a simple truth that there's just this inverse relationship. The total collected energy for the two objects is the same. Okay? There's no, if you do anything to collect what energy they have or to create a counter force to the energy they have, they both have the same number of joules of energy. They have the same amount of capacity. They've collected the same amount of wind. All right, and all you're saying is yes, obviously the lighter boat goes faster than the heavier boat. Okay, and that's it. But it's the same amount of wind. They both have the same quantity of energy inside of them, and it's just that you've inverted its expression. In one of them, the expression is you have it in its mass. You have more masses that have less energy, less velocity, and in the other form you have fewer masses but more velocity. I mean, it's the same. It adds up to the same quantity. And so, but again, so they used.
But look at the work they.
So here they're saying what the work is. Now we all know that it's really easy to lift light things, and it's really hard to lift heavy things. So they're going to completely ignore what the real work equation is, which is we know it's more work to lift heavy things than it is to lift light things. And they're going to say the work is the same in gravity. That essentially in this analogy, they're making this fundamental error of thinking work doesn't care how heavy something is. Of course it matters how heavy it is. You have to do a lot more work to lift a heavy thing than you do a light thing. Just a simple fact, and they just totally ignore it for the purpose of distorting perspective here. And that's all that was ever done in this physics. This physics is just a diagram in distortion. Everybody presented evidence that supported their argument, okay, and it was all presented as propaganda for the purpose of validating a theory. It wasn't for the purpose of let's find the truth. I'm not saying some of these people weren't trying to find the truth, but I just mean they all had a conclusion and they were trying to defend it. And all their conclusions were all religious and stupid, so none of them had the right answer anyway. It's an argument between two nutty religions, and they're both trying to quote mine the Bible to say my religion's right and your religion's wrong.
Perform.
So very nice animation, nice theoretical experiment, but it demonstrates, and it sort of demonstrates the truth, frankly, because everybody knows you throw a light thing with the same energy that you throw a heavy thing, the light thing's going to go a lot further. Same explosion underneath two objects. One's really, like if I double the weight of the space shuttle, it's not going to fly as far. So obviously, with the same energy, so I gave it the same energy, yet it doesn't go as far. We know that should be the right outcome. That's how gravity works. So just think of the bigger object as the heavier object. Just think of it as surface area or whatever, because the two are being proportional here. That the bigger object is now collecting more force against it. It has more sail, so it's going to collect more force. So it's going to stop much sooner. Because while one of them's collecting 2 bits at a time per second, the other one's collecting 4 bits of energy per second. They both have the same energy. They both have the same value, 18 at the bottom. And now the heavy one has just collected 4, let's say. The other one's collected 2. And that's the relationship.
The weight of 2 ascends 1 unit of height, giving a work and power of 2.
Right, so again, they're sitting here telling us that height means power, when we know that the height isn't proportional to how high you have to go, has more to do with how fast you're collecting the opposing force. And obviously the bigger object is collecting the force at 4 times the rate as the smaller object. Yeah, because the mass is smaller and the velocity is higher. There's 2 things to get over.
While the weight of 1 ascends 4 units, giving a total of 4. Thus, equal quantities of Descartes' quantity of motion brought about.
Yeah, so equal quantities, and obviously the sail that's twice as big on a heavier boat. Let's see, how to say that. Well, I'm just saying it's the same thing as the acceleration. The fact is, we already know that from Galileo. So Galileo already knows, okay, that there's this weird relationship, okay, that that to double the velocity you have to go 4 times higher. So that's already a known fact. So the fact that it turns out that way, yeah, we already know that's the way the rules work, because we can do that with things that have equal masses, and we can just figure out that, yeah, equal masses, but I gotta go 4 times higher to get the same velocity, to double the velocity.
Different results. This means that Descartes wasn't really measuring the power residing in movement.
All right, so I don't think that animation is actually correct. It's twice as high, because you've only doubled the amount of you're only going with half the mass and twice the velocity, and so you don't need to go 4 times as high because the two have inverted masses. Well, something like that. Well, anyway, right, it doesn't matter. I should have thought that through a little bit better than I just did. But I'm just saying it's already something we know that's what gravity does. So the whole argument here, right? So let's just cut to the end chase. The whole argument is that we know different ways of seeing energy produce different results because different forces impose change in different ways. And so the rules of gravity are that it's a rate that you collect, because there's a rate of the gravity, and the more mass you have, the faster the rate. You collect it much faster depending on mass. And so that relationship means you can't use gravity as a very good way to measure energy. Now we know that things like springs are much better. If I have a spring, we know that its compression rate is kind of consistent. It's not necessarily that that it obviously gets tighter and tighter and tighter as you compress the spring pushes back with a little bit more pressure. So it's not like you push the spring halfway, that this is the same amount of energy as this. But what it will tell you is there'll be a certain movement of the spring, and that if they're two different energies, they won't compress the spring to the same place. But if they are the same energy, they will compress to the same location. They'll give you back exactly what you put in. So the point is if you do have two objects that are different sizes, but and different velocities, okay, velocity 2, mass half, that they'll compress the spring the same, reflecting the fact that there's a total units. Let's just say 18 units of energy. 18 units of energy will get you to the same place on the spring. So that's the real way to measure it, okay? It won't be, and if I had something that had twice as much energy, so if I use two things with the same size, same mass, but I give them two different velocities, velocity 2, it won't necessarily go twice as far, but it will go further into the spring. And there's a place on the spring, like it's just measuring weight. The same thing happens when you step on a scale. It's just measuring how much you're collecting, how much of the gravity you're collecting. Your mass tells you how big a collector you have, and so it's just giving you the weight of your collection capacity. And the spring is going to do the same thing when objects encounter it. They're going to tell you what my bias is in a direction. How many bits of this energy stuff do I have? Yeah, so it's not that complicated. Yeah, so that's probably the way to measure it. Or else you just measure it by, you throw the two things at some object, a pivoting, just a board on a pivot, and then you have them hit at the same time. And if they have the same energy, then the pivot's not going to go anywhere. Both two things will hit, and they'll equalize each other's forces, and that'll be it. But if they're unequal, or if they arrive at the uneven times, it'll be a little messy. But the end result will be even if they're even times, the odds are you're still going to end up with a final position of 0. And if you make one of them a little heavier or one of them goes a little bit faster, then you're going to have a tilt in that direction, because that extra energy will mean there's a bias in that direction. So that'll give you the right answer too. So those are the experiments we're looking for. If somebody can find those simple experiments, that's what we want, and that'll tell you the truth. And we can, finally just say, well, there's pretty conclusive evidence. If we use a good way to detect something that gives you a real accurate reading of how much energy you actually have, then you'll get the answer that mv equals energy. That's the truth. That's the one that will always give you the right answer. And that this 1/2 mv squared is, first off, they invented the 1/2 much later. It was originally just mv squared, which is colossally off. I mean, you can just understand that it just doesn't make, you're going to be making more energy just by speeding something up in insane proportions. And the half fixes that a little bit. It takes the edge off the square, but clearly, even if you do increase velocities by a lot, cutting the mass in half isn't going to fix the fact that you've squared the velocity, and you're going to get insanely disproportional numbers for your energy. All right, but it's just this should be resolvable by modern man, right? The fact that Descartes and Leibniz and Newton and all the other people advocating for a position couldn't sort it out in the 1800s, the 1700s, and the 1800s. I mean, by now we should have this well sorted. That, oh yeah, we understand these are different forces. You can't just say F equals ma, and pretend you've done all you have to do, because it depends on how the force is transferred. And we know, like I said, that inelastic collisions take a matter of milliseconds, where these other collisions with force, like your collision with gravity, happen over time. There's a rate of the force, and the rate isn't instantaneous. You don't go 10 meters per second in the first half a second of your exposure, or even the first second. You have achieved the velocity, but you didn't have the velocity through the whole trip. So it clearly takes time for the force to affect the matter. And that's very different force law than a force that happens because a wrecking ball hits you. All the force is instantly transferred. Instant's a bad word. I shouldn't use it. Very quickly. Tiny amount of time. All right. So anyway, that's probably enough. Yeah. So I mean, the challenge will be, let's do the experiment. If we can't find it, let's do it, and let's do it for big money, as big as possible. Okay, because I'm quite confident MV is going to win, and that there's no rational excuse for presuming that you can create energy merely by banging heavy things into small things. Because that's the implication of 1/2 mv squared, is that if I transfer energy from heavy things to light things, I'll make energy. And if I transfer small things into big things, I'll lose energy. And it's a silly notion, just nonsense. You don't make or destroy energy. So that concept can't be correct. All right. I mean, it's so fundamental to this physics. I mean, I probably in one of the future videos, I'm going to replay where they measure the mass of an electron. And I'll show you how, look, they're using that silly formula. So they're telling you how many joules an electron has based on that silly formula. That you're going to completely get an exaggerated number. You're going to get the wrong answer. All right. So till the next time. So I mean, all of physics has been corrupted by this stupid mistake. I mean, it's really stupid and glaringly wrong. And only loonies, okay, like Lyndon LaRouche or somebody could buy into this crap. I mean, the fact that LaRouche, this is LaRouchian physics that you're defending, should scare you a little. You know, that some of the worst propagandists on planet Earth are on your side. That should bother you. You know. But anyway. Alright, so till the next time and such. You know, I have to make another concise video on the subject now that I've read a lot more about Leibniz and Descartes and the way they presented their arguments. And again, like I said, it's almost too silly to even say why should we even start at that point, because these are just really two different religious interpretations of physics arguing with each other. And they didn't even understand the concept that there's energy in the atom, and that the atoms have, you know, that they are the thing containing the energy. They're the things being affected by the forces. I guess a lot of modern physics people don't understand that either, that gravity is a nuclear force. It doesn't affect whole bodies. It affects individual atoms, and the individual atoms interfere with, you know, transfer the force essentially. But it's, you know, it happens on the smallest scale, not the big scale. It's happening in the small universe, not the big universe. The big universe is doing what the small universe tells it to do. You know, and that's a kind of one of these fundamental things, like believe in God or don't believe in. You know, it's as clear as evolution versus, you know, theology. And physics is still doing a lot of theology. And so that'll be that. So this has been a DraftScience video presentation. Till the next time and such.